All right. Hello, everyone. Can you hear me? Hello, hello. We have people from India. Where else? Colorado. Mountain View. Let me know if you can hear me. Let me know in chat, please. All right. Hey, Alex. Yes, we can. Hey, William. Thank you. Thank you. All right. Sweet. We got an exciting live stream today. We have Tomás from NotDiamond. He has decided to come chat with us. Very excited to talk to you about it. I want to tell you kind of how I met him. I'll bring him on in a second. And we could talk about what NotDiamond is, what routing of LLMs is, why it's important, and all of that good stuff. So let me just bring him right in. All right, let me unmute you. Tomás, can you say something?
Hey, can everyone hear me okay?
All right. It's like by the way, like a 15-second delay. So if you're looking at chat, it'll be a little bit before they agree. But I hear you, so I know you're there. Um, very cool. Let me just adjust the screen a bit. All right. Yeah, Tomás, welcome. Thank you. Thank you for taking the time to chat with me. I there's a lot to talk about. Crystal clear. All right, everybody's saying all good. Thank you guys. Thank you for letting us know. Okay, so we have a lot to talk about. I want to actually talk about how we met at first, and then we can get into NotDiamond and everything that you guys are doing over there. So I'm an investor in NotDiamond, and I put out this video. I don't know, maybe a few months ago, and it was called Abstract AI. And it was this idea that there needs to be this layer between business logic and the models. And so everything from routing to the appropriate LLM to prompt management and all of this other stuff between the actual business logic when you're building an AI application and then the models themselves. Because there's a ton of different models right now. They're getting better. They're also getting smaller. They're also getting more specialized. And after I published that video, about like 700 people told me, "Oh, hey, you're talking about NotDiamond." And I think, Tomás, I reached out to you after that. I can't remember who reached out to who, but I was like, "Oh yeah, you already built this thing that I had thought," and I was really excited to chat with you. And we met, and we kind of got along well. And that is how we met. Is that how you recall it?
Yeah, I mean, actually, the same thing happened on the other side. As we were, releasing Not Diamond, we had so many people saying like, "Hey, like Matt Berman has been like tweeting about this and making videos about this." And I think you had actually signed up like the same day I had emailed you, and we like both emailed each other at the same time. So it was kind of like perfect, worked out perfectly. And yeah, it's been so awesome having you on board.
Awesome. Abhishek says he's been using Not Diamond for a month and a half. It's very nice. All right, let's stop here. Tomás, give us an overview. What is Not Diamond? How does it work? Why is it important to think about routing?
Yeah, so NotDiamond is an AI model router that automatically determines for any given query which LM is best suited to respond. And we actually outperform every foundation model on every major benchmark, so higher accuracy, while also reducing costs and latency. And I'll also say, in addition to our out-of-the-box router, we offer an interface for developers and teams to tune routing to their own preferences and their own data. And we can get into how that works later. But the reason this is important is that, first of all, I'll speak from personal experience. I was building something at the application layer and started running into this problem myself and saw that not only were all of my founder friends struggling with this, but very sophisticated teams at companies like PayPal, Airbnb, Uber were trying to build their own routers internally and find that to be a really hard problem to solve. And also a really hard problem to stay solved because every week a new model comes out or an old model gets updated. And the kind of basic belief that drove us to build this is that the future is not going to have one giant monolithic model that everyone uses for everything. Instead, we're going to have many, many, many different models and inference engines, fine tunes, agents, etc. And figuring out when to use which model, both in terms of which model is going to be the best suited to handle a particular query, and then also there's a lot of queries that you can use a much smaller, cheaper, and faster model instead of a giant powerhouse, say like O1, where you can drive enormous computational efficiencies. Now, there's big gains, but there's also, a lot of complexity to managing and updating a system like that. And that's why we decided to build NotDiamond to make it easier for developers to leverage multiple models seamlessly to improve their output quality and, yeah, drive down costs.
Yeah, and Tomas, I've been thinking about this for a while, especially as we get all of these really nice, smaller, very efficient, specialized models. And some models are good at something. Some, like for example, O1, really good at logic, really good at reasoning, really good at planning. But you don't always need O1, and a single query from O1 can cost tens of cents up to dollars even. And so you have all these other models that are good at writing, are good at math, and they're smaller and they're more efficient and they're less expensive. And I realized that that is really the future is multi-model, not multimodal, but also multimodal, but multi-model. And there needed to be this routing layer. So when did you originally have this insight from your founder friends and other folks you were talking to?
So we started kind of exploring this exactly a year ago in September, and we were still building the other kind of project that had given rise to this problem. And then around the end of last year, we decided to go all in on building this model router.
Awesome. I was just muting myself. Okay, so and then I also, if you mentioned it, sorry, but you also open sourced something just about a week ago. Maybe you want to talk about that a little bit?
Yeah, so we started building this at the end of last year, and then we are lucky to be backed, in addition to yourself, also by folks like Jeff Dean from Google, Julian Chamot from Hugging Face, Jan Stoica from Databricks and Anyscale, many other amazing folks. And we're building this over the course of the year and then launched publicly a couple months ago. Now, on the path to launch, we actually iterated through many different architectures. And one of the architectures, the kind of previous generation of our router before launch, was something that we just open sourced last week. And it is a random forest classifier that is a pairwise model router. So what this does is it lets you route between two models of your choice. And essentially, I was excited to share this because it beats all other open source and closed source options out there in terms of performance. It's very data efficient. We open sourced both a bunch of model pairs, so GPT-4o and 4o Mini, Llama 405 billion and 70 billion, Llama and Sonnet, and then also the training and inference code. So you can just go straight to GitHub, clone the repo, and start using it yourself. And then before we launched, we built kind of a next generation of that lets you route to not just two models, but N models that we support, in our API up to 40 models, and you can also route to your own custom models. And there's a bunch of other improvements that we drove as well. But I think that, part of the reason we wanted to open source this is that I think routing is like really, really important for our ecosystem. it can help drive us towards more specialization and computational efficiency. Uh, Moving to a world where we have networks of smaller, more specialized models also drives a lot of AI safety gains as well. Smaller models are more interpretable, more steerable, auditable. And lastly, I think that building this kind of infrastructure can shift us away from an ecosystem where you have one provider or one company that is kind of the winner takes all in the model provider ecosystem. And I think a fragmented inference layer with many providers and many models gives more choice to the market, to users, to developers, to end consumers. It drives down costs and drives up innovation. So that's kind of why we think routing is so important, and partly why we were excited to, open source this last generation, which we call RORF, routing on random forests.
Awesome. Okay, quickly chat if you have questions for either of us, just put them in the comments or the chat. We'll read them. We'll answer them as we go. This is kind of free form right now. So just to like break it down at the most basic level, an engineer or really anybody will come to NotDiamond. They will send you a prompt. You will evaluate the prompt for whatever signal you're looking for, and I'm going to ask you about that in a second. And then you route it to the most appropriate model. The model responds, and then you pass back that response. What are the signals you're looking for? Like, what are you optimizing for when you receive that prompt? How do you know which model to actually send it to?
Yeah. Yeah. So I'll speak to that. And I'll also just say, so the architecture there that you described is nearly exactly right. There's one detail that I'll say is different where you send a message, NotDiamond returns a recommendation for which model to use, and then the request goes out client side. And what that means is that we're not a proxy, so you can take the recommendation and then call that model locally through a gateway directly from the provider. And that gives developers more agency. It lets us add on more kind of privacy and security protections for developers. So that's the one thing I'll correct there, that we're not a proxy. We're essentially a recommendation engine.
Got it.
And then to your question of like, how do we make these recommendations? So we have this out of the box router, which you can spin up with in less than 5 minutes. You can, yeah, if anyone's watching and you want to kind of prove me wrong, you just go to notdiamond.ai, sign up for an API key. We have a quick start example, and you can probably get up and running in, yeah, five minutes. But this out of the box router, we have trained on a very robust cross-domain evaluation data set, everything from code generation to text summarization to medicine to law. And we learn a mapping from input prompts to rankings for models. So, given this prompt, which model is best suited to respond? And then you define, when you're making the call, which LM specifically you want to route between. Maybe you want to route between Claude and Llama and Mistral, or maybe you want Perplexity and OpenAI, or just multiple OpenAI models. You decide that, and then given the rankings for the prompt that you've entered, we're able to, given a novel prompt, we're able to predict the rankings and then return the recommendation. And that's the other important piece, that this is a predictive routing architecture. So it's not like we're calling all the models, evaluating the responses, and then giving you back that best response, just because that would be very slow and expensive. Instead, we're able to do this predictively, and this is architected off of a long history in ML of recommendation systems. Now, on top of that, there's a couple ways that we let you tune this to your preferences, right? Because you can think of the out-of-the-box router as kind of our opinionated, general purpose cross-domain router. But on top, by default, we just route to the best suited, highest quality model. you can also define explicit costs and latency trade-offs so that we consider smaller, cheaper, faster models when doing so. It doesn't degrade latency. We also can improve or hyper personalize recommendations in real time based on user feedback. So if someone thumbs ups or thumbs downs, we can begin to learn for your application or even that individual user when we should be using which model. And we do this in a similar way to how TikTok learns a hyper personalized content routing algorithm for each of their end users. And then finally, we also offer an interface to provide your own evaluation data. So let's say you've evaluated a few different models, maybe even your own private models. You can upload that to NotDiamond and get back a custom router optimized to your data and your definition of quality. And so that's kind of essentially how this works from a kind of a more architectural level of how do we actually learn how to recommend the right model?
All right. So the fact that you're just giving the recommendations means it's going to be very low latency. Is that right?
That's right. Yeah. So we, particularly if you're deploying locally, the inference speed on our router is around 50 milliseconds. Now, if you're making the API call, there's an additional kind of network latency to that. So we're usually around 400 or 500 milliseconds for at around 100 concurrent requests. So still pretty low latency. But one of the benefits of routing additionally is that we can send certain queries to faster models, so you improve your net latency. And because it's a recommendation service, it's also very easy for us to deploy it locally to your infrastructure or your VPC.
Okay. And so let's say I'm a developer and I have an existing application. What and I want to put in place NotDiamond. What does that process look like? So I have, let's just say I'm using OpenAI's API, and I have, I'm generally using 4.0 just across the board consistently. How do I start putting in place NotDiamond calls? Is it just a drop-in replacement? How should I think about that?
So we do have specifically an integration for OpenAI where you can kind of just change 2 lines of code and start routing. Basically in your OpenAI call, you specify the model. And instead of specifying a string for that, you can specify a list of strings. So the various models that you want to route between. Basically, if you are making LM calls, you're somehow getting a message, an input that you're gonna send to these LMs or to this LM, and then NotDiamond kind of goes in between you've received the message and you're gonna send it to the LM, and then you just basically stick in this recommendation step where you get a response from NotDiamond that shows you which LM specifically you should send the message request to. So that works well if you're using OpenAI, if you're using something like OpenRouter or Bedrock, or have different request code for different model providers that you're using. It basically doesn't require you to rip out or change any of your existing pipeline. You just stick this additional recommendation step there before the actual model call goes out.
And I know you mentioned this already, but how many models does, NotDiamond currently support?
So currently we support something like 40 in our out-of-the-box router. We can onboard new models very quickly, so it usually takes us 24 to 48 hours to add a new model. So that also means
Wow.
that if there's a model that we don't support that you would like us to support, you can reach out to us, and we'll work to onboard that for you.
And maybe a little bit behind the curtains right now, whatever you're willing to share, what does that onboarding process look like when a new model comes out? How do you determine if it's worth integrating into your system? And then what does that process actually look like?
So usually, we're a small team, so 24 to 48 hours, it's awesome turnaround, but it's
Yeah.
also, we have to be judicious just given our team resources about which models we do and don't onboard. And so the main thing that determines whether we onboard a new model is has someone asked for it. And we actually try to be pretty aggressive about only building things that people ask for. There's a lot of really exciting models that come out with great benchmarks, and nobody says, "Hey, can you guys add this to Not Diamond?" So there's, I think, can sometimes be a gap between what's exciting to the research community versus what's exciting to or meaningful for developers building applications. So um, that said, the way that we onboard these models is our router is able to essentially learn these rankings independently. So we don't have to retrain the entire model router from scratch. We can kind of onboard new models in a pretty efficient manner, and we run it through our evaluation pipeline, and then are able to add the kind of rankings for that model into the rankings that the router outputs for novel queries.
All right. So, what are you seeing? Like, what are the most popular models being routed to right now, from your clients? And then what do you just maybe list a few that are you're like, hey, this model is especially good for this type of workflow or this type of use case?
Yeah, so well, I'll say one thing that we've seen, which is pretty interesting, is Perplexity is actually a pretty popular model, and I think it's a great example of routing. Obviously, you can build search tools and et cetera into any LM you're leveraging, but I think Perplexity has certainly done a very, very good job of building that, abstracting that complexity for you. And it's also the kind of a model that you wouldn't want to use for every kind of question. So I've even found, for example, in my own coding workflows, that sometimes Perplexity is a better use on certain parts of the problem or certain questions than other models. The other one that has been surprising to us is that Mistral Large is actually performing very well. And so one of the metrics that we can use to improve our routing is also the feedback that we receive on routing decisions. So if you're submitting feedback, you can use this to improve the recommendations that you're getting, and this helps gives us better insight into when which model is performing well. And so we've actually seen in some cases, preference data skewing towards Mistral over GPT-4o, which is really, really surprising. Claude 3.5 Sonnet is probably across the board the most popular model. And then obviously 4o is up there too. We're still not seeing a ton of usage on O1, and I think that speaks to why, like, how this is seems to be really playing out as a model that is used for very specific use cases. And I think, again, like a great example of routing where you don't need to use O1 for everything under the sun, and you would probably go bankrupt if you did.
Yeah.
Um,
Yeah.
but it's extremely powerful when you do know the right kind of questions to leverage it on.
So, so,
And
so
then,
Thomas,
yeah,
let me interrupt for just 1 second. It's so interesting that you say that about O1. When I first saw it, obviously I was blown away. It's really an incredible model. But I had messaged or I posted on X, 95% of use cases do not need this. And not only do you not need it, you really shouldn't use it because of the latency and the cost. There are just so many better options, and maybe 95% is even being conservative. So I'm glad that you're seeing the same thing with your own benchmarks. And yeah, please continue.
yeah, and I mean, I can even show you a quick demo of like how routing works with O1 if that's interesting or if folks want to see that in the comments. But definitely, I think it's like by far the most powerful LLM or model language model that we've developed. But yeah, it's a very specific kind of model that really shouldn't be used on everything. So, and I think I'd actually wrapped up or said what I was wanting to say in response to your question. So, happy to speak to another question, or like I said, like share some kind of examples of what this looks like. But yeah.
Yeah. It would be cool to share your screen. I need to figure out how to do that. So just give me 1 second.
Okay. I have a screen share button too. I can try
Yeah, go
clicking.
ahead and click it when you're ready, and I'll make sure that it gets placed on here, hopefully. And if not, we're going to go straight to questions. So, by the way, chat, if you have questions, drop your questions, and we will answer as many as we can.
Let's see here. Okay. Can you see this?
Okay, 1 second. I just need to add something. Add source. I think this is going to work. Nope, I do not see it. Why don't I see it? Team cam. There we are. Okay, 1 second. I'm going to put it on the screen. Just give me a sec. Okay. I'm going to clean it up as we're going. I know it looks a little wonky right now.
Cool.
I'm just going to share the whole screen. Yeah, you can start talking and I'll clean it up as we go.
Okay. Yeah. Well, I'll just mention also before I jump into this, if you want to try, building this, we built this in Streamlit using NotDiamond. There's a repo here, NotDiamond examples that you can kind of just clone and try out yourself. But basically here, I'm gonna send a relatively simple question, right? Or explain merge sort concisely. So here it's going to know to use a small model. I've made I've set our routing trade-off to cost, so it's going to know to use cheaper models when doing so doesn't degrade quality. And you can see that costs half a cent. Now, if I ask a more complicated question like write a login component in React, it's going to send us to a more powerful model, in this case, GB40. Now, one of the questions you asked earlier too is like domains where we see different models performing better or worse. Like one of the interesting things we've seen in our evaluations is that GB40 tends to be a lot stronger on JavaScript and TypeScript, but Sonnet is actually stronger on Python, and it looks different for different languages. And obviously, within the languages, there's different subsets. But here
And
you can
does your routing algorithm have all of those features in it? That it just knows like, hey, this model's better at Python, this one's better at JavaScript.
exactly, yeah. So like,
That's so
let's
cool.
say that a sort algo in Python. So now it's sending it to Claude 3.5 Sonnet because it knows that it's a stronger model on this kind of a question. Now, if I ask a much more complicated question, like implement a parallel merge sort algorithm in Python, there's a ton of different kind of requirements here, steps, etc. And now it knows to send that to O1. And this is where this model really excels, breaking down these kind of complex multi-step tasks, being able to explore different kind of solutions. But on the other hand, of course, it's really slow and super expensive. Now, this is much better than going around in loops with, I don't know, like everyone probably knows that frustration of using a model and just you're going around in loops with it. it is not able to get what you're requesting, and you kind of just have to eventually set it aside. But so this is better than that, but definitely a model to be used sparingly. So
Yeah, well,
that's
it's
kind of
still going.
it's still going. It's really thinking here. And I think part of what, a lot of people, I know this has been making the rounds, but part of what makes this model so slow and expensive is all of the hidden reasoning tokens, which aren't actually included in the output. So even though O1 is 6 times more expensive on a token basis than 4.0, because of all of that additional hidden reasoning tokens, it ends up being up to 30 times more expensive than 4.0. So yeah,
Wow.
unless
Okay.
this is still running, this one is probably going to be pretty expensive.
Okay. I'm gonna switch back to just us.
Sounds
We got a
good.
bunch of good questions, Tomas. So if you don't mind, we'll just jump into some of these questions.
Let's do it.
Um, Eric Buse. Can I tell it when to recommend my own private local LLM?
Yes, you can. And the way that, so you can actually you can use our custom router training interface to route to proprietary models, to local private models, to fine-tune models, to agents. You can even define a human being as an inference endpoint, and we'll learn how to route between all of these. So absolutely, we can route to both proprietary public models and your own private local models.
Wait, I have a follow up question. What's the use case for having a human model?
Well, I think there's a lot of examples in business functions where it's something that a human or humans have been doing, and we're now looking for, well, what are the subsets of this domain that we can use LLMs for? One example of this is customer support or say HR tasks, etc. And it's impressive what LMs are able to accomplish there, but there's still, certain kinds of thorny questions or questions that rely on kind of very, you know, implicit institutional knowledge that still require a human in the loop. And so those are use cases where we can learn when you can send it to an LM and when it should be going to a human being or even which particular human being.
So if I ask it a trolley problem, it's gonna route to a human. What do you think?
So we don't have a human in our out of the box router. Uh,
Yeah.
so, but you
So I'd have to
can
train it to do it.
exactly. So you could have any kind of ethics questions going to a human, or even more fine grained than that. I think what's impressive to me is that with our custom router training workflow, you can get performance gains even on very narrow domains. So, for example, we have in our docs an example where we together walk through training a custom router on the human eval dataset, which is just Python coding. And so, super narrow domain, and we're able to actually, just by learning how to route between models, improve performance over the best individual model by 3 percentage points on the benchmark, which is, a pretty big deal because companies will spend tens or hundreds of
Right.
millions of dollars to achieve that. And so you could have, on ethics, we can see, okay, this is something that an LLM is capable of, and this is something where it just short circuits and it cannot figure out how to respond rationally.
Yeah. And actually, I think that's a good point. Big gains are great, but even incremental gains at scale are incredible, right? So if you are a multi-billion-dollar company building, even forget the kind of the cap of your company, but if if you have really high scale use cases, then incremental improvements are actually extremely valuable.
Yeah, and especially because these, increasingly we're using LLMs recursively, right? So we're taking the output of one LLM and then feeding it into another LLM, and we're building the outputs build on top of each other. So every percentage point that you increase gives you exponentially higher, quality at the end of that chain or that loop. And what I think is also exciting for us is that we can get these incremental benefits in accuracy and quality while drastically reducing costs at the same time. And one of our users was able to improve their measured output quality actually pretty significantly, by 14%. Sorry, I'm getting this backwards. They increased their quality by 72% while reducing their cost by 14%. In another case, we saw someone increasing quality by a couple percentage points while increasing their accuracy by a couple percentage points while dropping costs by 30%. And that I think is like the pretty exciting thing about this paradigm, that we can kind of do both. We can improve quality while reducing costs.
All right. Next, GeoGotch has an interesting question. I think I understand it. I'm going to pose it to you, and then you let me know. Is the future going to be routers routing to LLM-specific GPUs? So basically GPUs that are custom built for specific types of models. And I think maybe a preface for that is, I forget the name of it, but there was a company that is creating essentially ASICs for the transformer architecture. So maybe that's what they mean, but hopefully that's enough info you can kind of generally understand how to answer that.
Yeah, so I think I understand the question. So there's in multiple ways that we can think about routing. So one is just at the inference level, like the model itself, which model is best suited to respond. And uh, in our out of the box router, we kind of assume the provider's costs and latency. Now, you could also define your own costs and latency there, if you're calling a model locally or you have a contract with one of these providers. There's another routing layer, which is at the inference and cost layer. And so if we have special purpose hardware that can help drive significant latency or cost gains on some of these models, we can also be learning to route between, okay, you have Llama, you have a ton of different providers which are offering Llama, and which one is doing that cheapest and fastest today or this hour or this minute, depending on your location. And there's some interesting work being done there from some other folks in the space. We're focused more on the just the recommendation piece, and then we let the actual request orchestration be handled client side. But it's a great question.
Yeah. And we have two more that you answered, but we'll just re-answer them because I'm sure people joined a little bit later in the stream. So Raha asks, what is the latency when it comes to selecting the correct model to use? So what kind of latency can an API user expect?
So on our API, you can expect between 300 to 500 milliseconds, depending on the load. We handle 500 milliseconds at 100 concurrent requests, so that scales pretty well. And then if you have deployed locally or to your VPC, the actual inference speed on our router is around 50 milliseconds.
Awesome. And then GeoGotch again asks, do you take a cut like an advertisement type routing system?
It's a great question. And when we were first starting to work on this, we thought about doing a model like that. And then we decided not to, because it sort of misaligns incentives. We thought about taking a cut. We also thought about
Agreed.
taking a cut of your savings. And both of those kind of like incentivize us to either send you to expensive models or cheap models. So what we shifted to instead is a just per request cost. So it's free to use our API up to 100,000 queries a month. I think that's also a decision we wanted to make, that we wanted it to be really easy to build using NotDiamond up to a pretty significant scale. And then beyond that, it costs a tenth of a cent per request. So if you break that down to like a token level, obviously depending on the nature of your inputs and outputs, but it generally works out to cheaper than the cheapest LLM. So we saw there, for example, GPT-4o Mini's response to this simple question of explain a merge sort concisely, couple paragraphs that cost zero point 0.6 cents. And so we're 6 times cheaper than that per request.
Okay, and I just want to repeat one more time. 100,000 free requests to if you just want to get started, if you want to tinker. I mean, that's not even tinkering level. 100,000 requests, that's pretty substantial. And then above that, a tenth of a penny per request. Awesome. Okay. So I saw a question in chat. Do you have any mixture of experts models? And if not, do you plan on it?
Well, so we do have we route to mixture of experts models in the sense that it's likely GPT-4o is a mixture of experts. Mistral, I wonder if your question is about mixture of agents, where you have like multiple different models responding, and then another model synthesizing the response.
Mixture of
Um,
agents. Yeah. Eric Boos asked that. Sorry, I misspoke.
Oh, no problem, no problem. So we don't support that in our out of the box router right now, though it's something that A, you could route to in a custom router, and B, we are considering adding into the out of the box router as well. And yeah, if that's something you would like to see, if you're watching this and you want to know, okay, when do we route to the mixture of agents versus when we route to the single model, just send me an email, and it's super valuable to hear feedback like that. So my email is t5@notdiamond.ai.
Yep. And I'm going to drop his email just in case you missed it in the chat. t5@notdiamond.ai. All right. I just dropped it in the chat. So we're probably going to go. Tomás, does it work for you? Maybe like another 10 minutes or so?
Yeah, perfect.
Awesome. So I got a couple rapid fire ones for you. Fobani, sorry if I'm mispronouncing your name. Does it only work for English prompts? Do you support multiple languages?
We do support multiple languages. It works for any language at all, and basically, I think that's another benefit of routing, that we can learn which models perform better on which languages.
Okay, and that's one of the signals that you're looking for is, hey, if something comes in Spanish, it routes to the appropriate model based on that model being really good at answering in Spanish?
Yes, though I would say it's a lot more fine grained than that. So it's not like we simply check the language and then send it to the Spanish model, because if it's Spanish coding or Spanish Python coding or
Right.
poetry, those may all look different.
Okay. Is Brian Hinton, is O1 Mini included in NotDiamond?
It is, yeah. So we support O1 Preview and O1 Mini.
Okay, Vishnu Kumar, did I say that NotDiamond is open source while starting the session? Maybe you can just clarify the part of NotDiamond that is open source now.
So we open sourced the last generation of our router, which we had developed pre-launch. So this is a pairwise model router, so it can route to two models that you specify. We've released some pre-trained model router pairs between popular models, as well as the inference and training code, and it's called RORF, routing on random forests, and that's all open source.
Okay, let's talk a little bit about the future of NotDiamond. Oratile asks, beyond routing models, are there other innovations that you're looking to explore within the context of NotDiamond? So I know, like when I was talking about abstract AI, I talked about caching, for example. It would be cool to have a middle layer that just handled my caching for me. So what other areas are you thinking about exploring in the future, whatever you're willing and able to share?
Yeah, so I'll say caching is definitely on the roadmap. We support joint prompt optimization, So if you're using something like DSPy or SAMO or any other prompt optimization framework, you can integrate that with your routing so that we send it not only to the best model, but the best prompt for the best model. And I think there's also a lot of exciting things to go down on that path. Uh, Additionally, I think that one thing we're excited about is we're going to be releasing soon more multimodal routing support. So routing between image generation models and vision models
That's so
and
cool.
more modalities besides just text. And then the last thing I'll say too there is just I'm excited to work with. This is kind of further in the future, but we talked earlier about how we can shift towards greater and greater specialization. And I think routing is a key piece of that because without routing, you kind of have to use a one size fits all model. And so, in the long term, what I would love to see is an ecosystem where anyone can build like a really specialized niche model and plug that into the network so that other people can route to those models and you can kind of get kind of instant distribution and revenue from that. And that way, everyone doesn't have to fine tune their own, financial data extraction model. And, it's the same as those other 30 ones that people have fine tuned. And then you have to constantly update that. Instead, we can let people who aren't either academics or billion-dollar companies build a company around actually building very specific specialized models. So that's kind of further down on the roadmap.
Awesome. And this next question I absolutely love. Abhishek Singh asks, what is the most interesting or unexpected use of Not Diamond that you've seen from your users?
So I think one of them, which for me really surprised me, was basically somebody. This is a startup. They have built one of their core workflows. Basically, takes in a piece of text that's been written by a human, and then uses an LM to make some very subtle modifications to it, and then returns the output. Then this is the kind of example that I in the past would have thought like you shouldn't use routing for this. This is like incredibly narrow. Just figure out the model that works best and use that, and call it a day. What really surprised me was this was the example that I mentioned earlier, where they were able to train a custom router on their specific workflow. And they had previously been using Sonnet, which was the best model overall on average. But just by routing between multiple models, they were able to significantly improve their measured output quality by 72% while lowering their cost by 14%. And that is really surprising and crazy for me, that even on these super narrow domains, that if you were just saying, okay, the category is task rewriting, so let's find out our task, our rewriting model and use that. There's actually a lot of nuance within rewriting, within Python coding. And that's why I'm kind of excited about the approach that we've taken that doesn't boil it down to these more kind of human invented categories.
This is a question from me. What tell us about the name Not Diamond?
It's a great question. So it's a reference to modal logic, which is the logic of possibility. And the diamond operator in modal logic means possible. So not diamond means not possible. And the story there is kind of how there's this really famous quote from Wittgenstein, this philosopher of language, who says, "Where of that which we cannot speak, thereof we must remain silent." So essentially, we can't talk about what we can't talk about, that there's limits to expression, to intelligent expression. And that's been a really powerful idea. But I think where I would, not necessarily disagree with it, but add to it is that the limits of expression have evolved over time. And the human brain hasn't changed in 100,000 years, but the technology of language has. How we speak, write, code, communicate, store information. And each of these kind of developments has expanded the limits of expression. And ultimately, the kind of motivation behind networking together diverse AI models is to continue expanding those limits of intelligent expression beyond what is currently possible. So, yeah, into what is not possible. The other reason is that it just sounds cool and it has a cool shape, and that's an important reason too.
The most important reason. Okay. Um, Thank you, Tomas. So, NotDiamond.ai, if people want to check it out, 100,000 free queries against Not Diamond if you want per month, right?
Yep.
Yep. Tenth of a penny after that. And if they want to find you on Twitter, where should they find you? How do they reach you?
Yeah, so you can follow me on Twitter. My handle is TOMAS_HK. And you can also email me. My email is t5@notdiamond.ai.
Awesome. Thank you so much for doing this. I appreciate it. Super proud to be a small part of your building this amazing company. So thank you, and thank you to everybody who joined the live stream and asked great questions. This has been super fascinating. So thank you again.
Yeah, thank you. Thanks, Matt. And thanks everyone for tuning in. Really, really nice to share with you all.
Yep. All right.